Welcome to Sunil Maths tutorial. In this video, we learn some problems from Riemann integration. Let us see. First, we learn this definition. Integral as the limit of a sum. Integral as the limit of a sum. Observe that. Suppose f belongs to capital R of a comma b. It means f is a Riemann integrable function over closed interval a comma b. Then integral a to b f of x dx can be written as limit n tends to infinity summation r is equals to 1 to n h into f of a plus rh, where h is equals to b minus a by n, where h is equals to b minus a by n. Put a is equals to 0 and b is equals to 1 in the above integral. We get this integral 0 to 1 f of x is equals to limit n tends to infinity summation r is equals to 1 to n 1 by n f of r by n, where h is equals to 1 by n, where h is equals to 1 by n. So working rule. To solve the problems depends upon this method, we use the following steps. First one, write the given series in this form. Write the given series in this form. Limit n tends to infinity 1 by n summation r is equals to 1 to n f of r by n. So whatever it may be the given series, you can put that series in this form. Limit n tends to infinity 1 by n summation r is equals to 1 to n f of r by n. And replace the r by n by the variable x. Replace the r by n by the variable x and 1 by n by dx, differential dx. And replace limit n tends to infinity summation 1 by n, summation r is equals to 1 to n. Limit n tends to infinity summation r is equals to 1 to n by using integral 0 to 1. So remember that first you have to convert the given series into this one and replace r by n by the variable x, replace 1 by n by dx, and replace limits summation with integral 0 to 1. Integral 0 to 1. Yes, let us solve some problems by using this working rule. By using this working rule. Yes, this is the first problem. Evaluate limit n tends to infinity 1 by n e power 3 by n plus e power 6 by n plus and so on plus e power 3 by n, e power 3 by n. Observe that limit n tends to infinity 1 by n e power 3 by n plus e power 6 by n plus and so on plus e power 3 by n. So that is the given series. That given series can be written in this form. You observe that carefully. Limit n tends to infinity 1 by n as it is, and this sum of the terms can be written like this. Summation r is equals to 1 to n. Summation r is equals to 1 to n f of e power 3r by n, e power 3r by n. In the working rule, we learned that 1 by n is replaced by dx. 1 by n is replaced by dx. Yes, this 1 by n is replaced by dx. And then r by n is replaced by x. R by n is replaced by the variable x. So you get e power x, e power 3x, e power 3x. And limit and summation. Limit and summation is replaced by integral 0 to 1. Limit and summation is replaced by 0 to 1. So you get simply integral 0 to 1 e power 3x dx. Integral 0 to 1 e power 3x dx. You can integrate simply this one. You get e power 3x divided by 3 and limits are from 0 to 1. Limits are from 0 to 1. You get simply e power 3 minus 1 by 3. E power 3 minus 1 by 3. But we solve this problem by using fundamental theorem of integral calculus. We solve the problem by using fundamental theorem of integral calculus. Observe carefully. So integral 0 to 1 e power 3x dx can be written as integral 0 to 1 f of x dx. Let it be equation number 1. What is f of x? E power 3x. And what is a? The lower limit of the integral. What is b? The upper limit of the integral. A is equals to 0 and b is equals to 1. Define pi of x is equals to e power 3x by 3. Remember that pi of x is nothing but the integral of e power 3x. Integral e power 3x. So we define pi of x as e power 3x by 3. Now calculate pi dash of x. What is pi dash of x? Pi dash of x means derivative of pi of x. derivative of pi of x, d by dx of pi of x. What is pi of x? E power 3x by 3. d by dx of e power 3x divided by 3. Simply you get e power 3x. Simply you get e power 3x. So pi dash of x is equals to f of x. It means the derivative of pi of x is f of x. The derivative of pi of x is f of x. Therefore, pi of x is the primitive of f of x. Pi of x is the primitive of f of x. If pi of x is the primitive of f of x, then very clearly, it is easy to apply the fundamental theorem of integral calculus. So, right, before going to apply the fundamental theorem of integral calculus, let us see some basic parts. Here f of x is equals to e power 3x, which is a standard function, exponential function. Clearly f of x is Riemann integrable. Clearly f of x is continuous and differentiable. So automatically it is Riemann integrable on closed interval 0, 1. And also pi dash of x is equals to f of x. Now applying the fundamental theorem of integral calculus, we get integral a to b f of x dx is equals to pi of b minus pi of a. Integral a to b f of x dx is equals to pi of b minus pi of a. That is nothing but integral 0 to 1 e power 3x dx is equals to pi of 1 minus pi of 0, because a is equals to 0 and b is equals to 1. What is pi of x? What is pi of x? We define pi of x is equals to e power 3x by 3. So by using e power 3 by 3 minus 1. If you put 0, you get 1 by 3. If you put 1, you get e power 3 by 3. The final answer is integral 0 to 1 e power 3x dx is equals to e power 3 minus 1 by 3. Now using equation 2 in equation 1, we get required result. Limit n tends to infinity 1 by n e power 3 by n plus e power 6 by n plus and so on plus e power 3n by n is equals to e power 3, here it is n, e power 3 minus 1 by 3. E power 3 minus 1 by 3. But you observe that this is the problem depends upon Riemann integration as well as fundamental theorem of integral calculus. But if you integrate the term here, if you integrate this term here, you simply get the final answer e power 3 minus 1 by 3. E power 3 minus 1 by 3. But here we use fundamental theorem of integral equation to prove that identity. Observe that this is the important question for 10 marks as well as for 5 marks. So keep learning. Wish you all the best.